Okay, in this video, I'm going to go over the study sheet for your first exam, which is on Monday, and it will cover all of Chapter 1. And of course, as you see on this review sheet, there are 20 problems here, and you will have a help sheet that will assist you with some of these problems that will be on your first exam. Starting with problem number 1. Here we got, if f of x is equal to 1 over x cubed plus 1, you want to evaluate the following. And in part A is f of 2, part B, f of k squared. So in this case here, I'm going to write the equation, or the function f of x is equal to 1 over x cubed plus 1. So in part A, we're finding f of 2. And in this case here, we just substitute the x with 2. So it'll be 1 over 2 to the third plus 1. And then if I cube that 2 cubed will be 8. So it'll be 1 over 8 plus 1. And then I'll end up with 1 over 9. So the value of that function at x is equal to 2 would be 1/9. Okay, part B, f of k to the second. Again, we're just substituting the x, but this time with k to the second. So it'll be 1 over k to the second, and that's going to be cubed plus 1. So I have 1 over, now, k to the second raised to the third power. I'm raising a power to a power, so we multiply the exponents here. So it'll be 2 times 3 will be 6. So it'll be k to the sixth plus 1. Okay, so that's problem number 1. Number 2, if f of x is equal to x squared minus 9 and g of x is equal to x to the fifth, we want to find g of f of u. So here f of x is x squared minus 9. G of x was x to the fifth. And we want g of f of u. Now notice the inside function is f of u. But let's go ahead and find out what f of u is going to be, since f of x is equal to x squared minus 9. So here f of u, we just substitute the x with the u, so it will be u squared minus 9. So that's what f of u is going to be, u squared minus 9. Now I can find out what g of f of u is going to be. Well, the inside function again is f of u, and f of u is u squared minus 9. So let's replace the f of u with u squared minus 9. And since g of x is equal to x to the fifth, and I'm finding out what g of u squared minus 9 is, I'll replace the x in the g of x with f of u, which is u squared minus 9. So this will be u squared minus 9, and that's going to be raised to the fifth power. Okay, and that will be as far as I can go with that particular problem here. All right, problem number 3. Here you're going to evaluate each expression using the graphs of y is equal to f of x and y is equal to g of x. Okay, so here is the graph where you have y equal f of x, which is a graph on the top, and on the bottom is y is equal to g of x. So here we're going to start off with part A, where you got f of g of 4. Okay, now what's on the inside is g of 4. We need to find out what value g of 4 is, and then whatever that is, we can find out what f of whatever that value is. Let's start off with g of 4. Here's my g of x, that's this red graph that you see here. And we find out what the y value is at x is equal to 4. So at 4, it's going to be 1. So g of 4 will be 1. Now we need to find out what f of 1 is going to be. Well, here's f of x up here, and the x value now is going to be 1, so the y value at x is equal to 1 will have to be 3. So f of g of 4 is going to be equal to 3. Alright, part B. G of f of 7. And here I want to evaluate that particular function here. Let's start off with the f of 7 first. That's the inside function. So f of x is up here, and 7 is on the x-axis, so we need to find out what that y value is when x is equal to 7. And in this case, it will be 7. So f of 7 is 7. So now I can find out what g of 7 is going to be. Alright, let's go to 7 here. The g of x is this red graph that you see. And it's going to be that point right there. At 7, the y value is going to be 4. So in this case here, g of f of 7 will equal to 4. Alright, part C. We got f of g of 6. F of g of 6. The inside function now is g of 6. So we're going to find out what g of x is when x is equal to 6. Well, at 6, that y value is going to be 3. So now we're going to find f of 3. So we need to know what that y value is when x is equal to 3 for y equal f of x. So here's 3 right here, and the y value at x equal 3 for y equal f of x is going to be 6. Okay, so f of g of 6 is going to be 6. Okay, and part D, g of f of 2. Now my inside function is f of 2, so here's f of x. Let's find that y value is when x is equal to 2 for f of x. At 2, the y value for y equal f of x is going to be 4. So I'm going to be evaluating g of 4. And then we go to y equal g of x, which is the graph that's in red. So at 4, that y value is going to be 1. So g of 4 will be 1. That means g of f of 2 would be 1. Okay, so that's how you use the graph to find out the value of each of those functions there. Alright, number 4. Find the graph of the linear function that passes through the points 2, 8 and 4, 14. So we're looking at the points 2, 8 and 4, 14. And here I want to find the graph of that linear function. But first of all, I need to find out what the slope of that line is going to be. Okay, if you remember the slope formula, that's going to be m is equal to y2 minus y1 divided by x2 minus x1. And in this case here, I'm going to let the first point, x1 will be 2, y1 will be 8. For the second point, x2 will be 4, y2 will be 14. And then we just substitute into that slope formula. So y2 minus y1 will be 14 minus 8 over x2 minus x1. That will be 4 minus 2. So if I do 14 minus 8, that will be 6. Divided by 4 minus 2 will be 2. 6 divided by 2 will be 3. So the slope of that line going through those 2 points would be 3. Now I need the equation of that line. So here I'm going to use the first point, 2h, and the slope of 3 in my point slope form, which is of course y minus y1, and that's equal to m times x minus x1. And in this case here, x1 will be 2, y1 would be 8. Now I could have used that other point 414. It really doesn't matter. You're going to still come up with the same equation. So here this will be y minus y1, which is 8, equaling to your slope of 3 times x minus x1, which is 2. And then simplify this using the distributive property on the right side. I have y minus 8, that's equal to 3 times x, that's 3x, minus 3 times 2, which is 6. And then finally, to get the y by itself, we'll add 8 on both sides. So that means y is equal to 3x minus 6 and a plus 8 would be plus 2. So this will be the equation of the line passing through those 2 points, 2, 8, and 4, 14. Y is equal to 3x plus 2. Okay. All right, number 5 is graphing the piecewise function f of x is equal to negative 2 minus x if x is less than or equal to 1, and negative 2 plus 2x if x is greater than or equal to 1. So in this case here, we're going to need a coordinate grid to do this. Okay, so here, let me go ahead and write down the function. In this case, that's f of x. This is number 5. F of x is equal to negative 2 minus x. We use that if x is less than or equal to 1. And then negative 2 plus 2x if x is greater than 1. Okay, so here's my coordinate grid. Now, for the first one, f of x equal to negative 2 minus x. The restriction there is where x is less than or equal to 1. So in this case, what I'm going to have to do there is pick values of x that is less than or equal to 1, like 1, 0, negative 1, negative 2. And then we go ahead and substitute those values into that particular function. So in this case here, if x is 1, then I'm going to have negative 2 minus 1, which is negative 3. For 0, negative 2 minus 0 will be negative 2. For negative 1, this will be negative 2 minus a negative 1, or negative 2 plus 1, which will be negative 1. And then for -2 minus 2, or -2 plus 2, which is 0. So those are my ordered pairs for that first function here. And now the next step will be to plot those points. So here, 1, -3 will be to the right 1 and down 3. 0, -2, stay at 0 but go down 2. -1, -1 to the left 1 and down 1. And then -2, 0 will be to the left 2 and on the x-axis. So this is what that graph will look like. It'd be like this. And notice I'm not drawing a line through that because it starts from x being less than or equal to 1. And now for the other graph, f of x equal -2 plus 2x. And that's if x is greater than 1. But I'm putting 1 here because I want to find out what value of x would it be if x was equal to 1, because that's going to represent what we call the hole in the graph. And then I'll pick 2, 3, and I'll stop right there because I only need like 3 points here. Now at x equal to 1, this will be -2 times, well, 2 times 1 will be 2. 2 plus that -2 would be 0. So at the point 1, 0, I'm going to have a hole in the graph. Now at 2 times 2 will be 4, plus -2 would be 2. And then x equal 3. 2 times 3 will be 6. 6 plus the -2 would be 4. And if I want to do 4, 2 times 4 would be 8 plus -2 would be 6. So that's going to be the ordered pairs for f of x equaling to -2 plus 2x. So here at 1, 0, I'm going to have a hole in the graph, because that point will not be included. And then 2, 2 will be to the right 2 and up 2. And then 3, 4. And then 4, 6. Okay. So this piece right here, or this part right here, represents the graph of the other part of that function. Okay. So this represents the graph of the piecewise function f of x equal to -2 minus x if x is less than or equal to 1, and -2 plus 2x if x is greater than or equal to 1. Okay. All right, number 6. Here you're going to use shifts and scalings to graph the function of f of x is equal to x plus 4 quantity squared plus 6, and you're going to state the original function. And I'll go ahead and write that function down. So this is f of x is equal to x plus 4 quantity squared, and then plus 6. And I'll go ahead and put in another coordinate grid. Like this one. And I think those transformations will be on your help sheet as well. So by looking at this, I have 2 different transformations. One of them, if you see that plus 4 here, in this case, that's a horizontal shift. And then the plus 6, that represents the vertical shift. Okay. Now, the original function, if you kind of look at this, that original function would be the function f of x is equal to x squared. Okay, because it's shifted to the left 4 and then goes up 6. And of course, the graph of that, I'll go ahead and do that in another color. And this is f of x equal to x squared. 0, 0, negative 1, 1, and 1, 1. And then over 2 and up 4. Okay. So this is what that graph looks like. And if you want me to, I can go ahead and draw in the table. Well, put in the table. For 0, that's 0. For 1, it'll be 1. Negative 1 is positive 1. At 2, 2 squared would be 4. Negative 2 would be negative 2 squared, which is also 4. So that's the graph of y is equal to x squared. Now, for the horizontal shift, I'm going to move to the left 4. And then for the vertical shift, I'm going to go up 6. Okay? Because it says plus 6, I'm going to move up 6. Plus 4, the opposite. Go to the left 4 with a horizontal shift. So for each point, let's start with 0, 0. I'm going to go to the left 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. And then for negative 1, 1, I'm going to go to the left 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. And for this point 1, 1, I'm going to go to the left 1, 2, 3, 4, and then up 1, 2, 3, 4, 5, 6. And for this point negative 2, 4, I'm going to go to the left 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. It'll be way up here. And for this point 2, 4, I'm going to go to the left 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. So this represents the graph of the function f of x is equal to x to the 4th, x plus 4 quantity squared plus 6. Okay. Alright, number 7 is finding the inverse of the function f of x is equal to 2x minus 1. So here's number 7. F of x is equal to 2x minus 1. So here we're going to find the inverse of that particular function here. So the first thing we do here is replace f of x with y. So it'll be y is equal to 2x minus 1. The second step would be to interchange x and y. So here that y becomes the x, and the x becomes y. So I get x equal to 2y minus 1. And then we go ahead and solve that equation for y. So the first thing I need to do here is add 1 to both sides to get x plus 1 is equal to 2y. Then divide both sides by 2. You'll get y is equal to x plus 1 over 2. And then the final step would be to replace the y with f inverse of x. So f inverse of x will be x plus 1 all over 2. So that's how we find the inverse of that particular function f of x. Alright, number 8. Solve the equation for x. And that's going to be log to the base 2. Log to the base x of 2 is equal to 1/3. I do number 8 over here. So we get log to the base x of 2 is equal to 1/3. Now to solve this equation, it is a logarithmic equation. What I'm going to do here is convert that into its equivalent exponential form. So that means this x right here will be your base. This 1/3 becomes the exponent for x, and that's going to be equal to 2. So this will be x raised to the 1/3 equal to 2. And now to solve for x is being raised to the 1/3, so what I need to do there is take the reciprocal of 1/3, which is going to be 3. So what I'm going to do here is cube both sides to the power of 3. So here 1/3 times 3 will be 1, so that's going to be x equal to 2 to the 3rd, which is 8. So 2 to the 3rd, well, log to the base 2, log to the base x of 2 equaling to 1/3 will give me the answer of x is equal to 8. Number 9, if log to the base b of x is equal to 0.33 and log to the base b of z is equal to 0.83, evaluate log to the base b of x times z. So in this case here, I'm going to write down log to the base b of x, what is equal to, that's 0.36, and then log to the base b of z is 0.83. And we want log to the base b of x times, this should be 0.33. I'm doing number 9. I was looking at number 10. So log to the base b of x times z is what we're trying to find. Okay, here we go. Now, here we have to apply the product rule for logarithms. Because we got the log of the product, that means I can expand that as the sum of their individual logarithms. So I can expand this as log to the base b of x plus log to the base b of z. Okay, so log to the base b of x, that's going to be 0.33, plus log to the base b of z is going to be 0.83. So 0.33 plus 0.83 would be 1.16. Okay. So if I do 0.33 plus 0.83, I would get 1.16 as the answer. Okay. That's problem number 9. Problem number 10. If log to the base b of x is equal to 0.36 and log to the base b of z is equal to 0.83, evaluate log to the base b of the square root of x over the cube root of z. So here log to the base b of x, that's going to be 0.36, and log to the base b of z is equal to 0.83. And we want log to the base b of the square root of x over the cube root of z. Okay. Alright, in this case, we need to apply the quotient rule first. Because we got the log of the quotient, we have a numerator and a denominator, we can expand that as a difference of the individual logarithms. So here, I'm going to expand that as log to the base b of, and I'm going to write the square root of x in exponential form, which is x to the 1/2. And then minus log to the base b of, and then the cube root of z, I'm going to write that as z to the 1/3. And now I'm going to apply the power rule here because I have exponents here. That means I can pull the power in front of the logarithm. So here, log to the base b of x to the 1/2, I'll pull the 1/2 in front of log to the base b of x, and then minus, for log to the base b of z to the 1/3, I'll pull the 1/3 in front of log to the base b of z. And now I can substitute what log to the base b of x is and what log to the base b of z is. So here I'm going to have 1/2 log to the base b of x, that's going to be 0.36 minus 1/3 log to the base b of z, that's going to be 0.83. So it'll be 1/3 times 0.83. Okay, so let's see, 1/2, I'm going to do 1 divided by 2 in parentheses times 0.36 plus 1/3 will be 1 divided by 3 times 0.83. And to, let's say, to 2 decimal places, this is going to be 0.46. So that's the approximate value of log to the base b of the square root of x over the cube root of z. Okay. So that's number 10. Number 11. Write log to the base 2 of 59 in terms of the natural logarithm. Then use the calculator to find the value of the logarithm to 4 decimal places. So here number 11. Log to the base 2 of 59. So this is where we use what we call the change of base property here. And the change of base property here, and I'm going to write this in terms of natural logarithms as they state. This will be the ln of what I'm taking the log of, 59. And that's divided by the natural log of the base, which is 2. So in this case here, we'll go ahead and use our calculator to find the natural log of 59 over the natural log of 2. So here I'm going to do ln 59, and I'm going to close the parentheses around the 59, because I only want the ln of 59 divided by ln of 2. Close parentheses, and then hit enter. Now here we want this answer to 4 decimal places, so this will be 5.882, and we're going to leave the 6 as is because that 4 is less than 5, so it'll be 5.8826. So that will be log to the base 2 of 59. Okay. All right, number 12. You're asked to convert 540 degrees to radian measure. Okay, 540 degrees, you're going to convert that to radian measure. Alright, in this case, what you're going to do here, you have to use the rule for converting from degree measure to radian measure. And if you kind of bear with me while I pull up my notes. Okay, and these will be on your help sheet as well. To convert from degrees to radians, you want to multiply by pi radians over 180 degrees. So in this case, we're going to take this right here, multiply by pi radians over 180 degrees. And what's going to happen is your degrees will divide out, and then you're going to do 540 pi over 180, and 540 divided by 180 will give you 3. So this will end up being 3 pi radians. Okay. So 540 degrees will be 3 pi radians. Alright, number 13 is to convert 11 pi over 10 radians to degree measure. So here we got 11 pi over 10 radians. And I want to convert that to degree measure. Well, it's the reciprocal of this right here. You're going from radians to degrees. From radians to degrees, you multiply by 180 over pi radians. So in this case here, this will be 180 degrees over pi radians. So in this case, the radians divide out and your pi's divide out. So you're left with 11 times 180 divided by 10. And this you can just do on the calculator. 11 times 180 divided by 10. You'll end up with 198 degrees. And that's the equivalent to 11 pi over 10 radians. Okay. That's problem number 13. Now, problem number 14 is to evaluate using a unit circle and give the exact value. Okay? And you will have the unit circle on your help sheet. So in problem number 14, we got the cosine of 5 pi over 3. Okay, this is the unit circle that it's going to be a better unit circle than the one that's on in this video here. But we can find 5 pi over 3 and find out what the cosine of 5 pi over 3 is. Well, here's 5 pi over 3 here. Now keep in mind, your cosine is always going to be your x value. The sine is always going to be your y value. So here, 5 pi over 3, the cosine of that would be 1/2. So for the cosine of 5 pi over 3, it's just going to simply be 1/2. Okay. Part B. The tangent of negative 3 pi over 4. Okay, now I don't like to use negative angles here. I like to use positive angles here. So anytime you have a negative angle, and I think I gave you a suggestion for doing problems that have negative angles in them. If you have a negative angle, you're going to add 2 pi to it. So what I'm going to do here, I'm going to add negative 3/4 to 2 pi. And I'm going to do this in the calculator by doing negative 3 divided by 4 in the parentheses plus 2. And I'm going to change this to a fraction. Press the math key and then number 1 for fraction. This will be 5 over 4. So this negative 3 pi over 4 is equivalent to 5 pi over 4. So I'm going to find the tangent of 5 pi over 4. using the unit circle. And also another thing, this is over 1, so, well, here we go, 5 pi over 4. That's the sine, that's the cosine and that's the sine. And I know tangent is sine over the cosine. So if I do the sine of 5 pi over 4 and the cosine of 5 pi over 4. Now for 5 pi over 4, the cosine is negative 1 over the square root of 2. But that's the same as saying the square root of 2 over 2. Over the cosine of 5 pi over 4, which is also negative 1 over the square root of 2. But that's the same as the negative square root of 2 over 2. And of course they're both negative since they're in the third quadrant. So here negative divided by negative is a positive. But notice the negative square root of 2 over 2 divided by itself is actually going to be 1. So the tangent of negative 3 pi over 4 will be 1. And then part C, the sine of negative pi thirds. Now again, I would add 2 pi to that negative pi over 3. And I'm going to treat that like negative 1/3, so negative 1 divided by 3 plus 2. Press the math key and change it to a fraction. This will be 5/3, which is actually 5 pi over 3. So I'm going to be evaluating the sine of 5 pi over 3. And then use the unit circle to find 5 pi over 3, which is down here. The sine is going to be this y-coordinate here. The y-coordinate is always the sine. The x-coordinate is the cosine. So the sine of 5 pi over 3 would be negative square root of 3 over 2. Okay. So that's problem number 14. All right, number 15. You're given the cosine of theta is equal to negative 4/5, and your theta is in quadrant 2. And here you want to find the exact value of the remaining trig functions of theta. Okay. What I would do here is draw a triangle for this one. Okay, this is going to be the xy plane. It's in quadrant 2. So here, here's theta. Now, you have to know that cosine is always going to be the adjacent side over the hypotenuse here. So the adjacent side is this side right here. And if it's in the second quadrant, that 4 has to be negative. The 5 is your hypotenuse. That's never going to be negative. So now I need to find out what this y-coordinate is going to be. That's the length of this side, because I want to find the remaining 5 trig functions. Alright, in this case here, this is where we use the Pythagorean Theorem, which is, of course, a squared plus b squared is equal to c squared. So in this case here, that a is going to be negative 4, so this will be negative 4, and that's squared, plus b, now let y just be the b, so this will be y squared is equal to c, which is your hypotenuse, that's going to be 5 squared. Then if I simplify this, negative 4 we squared would be positive 16, plus y squared is equal to 25. And then to get the y squared by itself, we'll subtract 16 on both sides. That's going to give me y squared is equal to 9. And then if I take the square root on both sides, the y will be equal to 3. So that's going to be the length of this side right here. Now from that, I can find the remaining 5 trig functions here. So for the sine of theta, that's going to be opposite over the hypotenuse. Sine of theta, that would be 3 over 5. Well, I already know what the cosine of theta is. That's going to be negative 4/5. I can find the tangent of theta. That's going to be opposite over the adjacent. That's going to be 3 over negative 4. Or we can say negative 3/4. And of course, the cosecant of theta is the reciprocal of the sine of theta. So here, the cosecant would be 5/3. The secant is the reciprocal of the cosine. So, if the cosine of theta is negative 4/5, then secant of theta would be a negative 5 over 4. And the cotangent of theta is the reciprocal of the tangent. So if tangent theta is negative 3/4, then cotangent theta would be negative 4/3. Okay, so these are the values of all the 6 trigonometric functions here for that particular problem. And that's problem 15. All right, number 16. You're to use the sum or difference identity to find the exact value of the expression cosine of pi over 3 plus pi over 4. So you're going to use either a sum or a difference identity. So in this case here, this is the cosine of pi thirds plus pi fourths. And these will be on your help sheet. Okay? Now it says cosine is going to be one of these two here. And it has a plus sign in between the two angles, so I have to use this identity right here. Cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine of beta. Okay? So, I'm going to write this as the cosine of pi thirds times the cosine of pi fourths minus the sine of pi thirds sine pi fourths. And then from here, we'll just go ahead and evaluate those angles. For the cosine of pi over 3, and again, you can use a unit circle if you like. Let's see, pi over 3 is right here. The cosine is this x angle here. I mean the x coordinate, 1/2. That's going to be multiplied by the cosine of pi over 4. Pi over 4 is here. The cosine, I'm going to use square root of 2 over 2. And then minus sine of pi over 3. Well, if this is pi over 3, this y coordinate is the sine of pi over 3. Square root of 3 over 2. Times sine of pi over 4. Well, pi fourths is here. I'm going to use square root of 2 over 2 instead of the 1 over the square root of 2. Alright, now let's simplify this. This part is going to be numerator times numerator. 1 times the square root of 2 is the square root of 2 over 2 times 2, which is 4. minus the square root of 3 times the square root of 2 will be the square root of 6 over 2 times 2, which is 4. Let me make that 6 look like a 6. And I can write this all under one single denominator. Since the denominators are the same, I can write that as the square root of 2 minus the square root of 6 all over 4. And that would be the final answer there. Alright, so that's problem 16. Number 17 is finding the exact value of the expression using the appropriate identities. Here we got the sine of 73 degrees times the cosine of 13 degrees. Sine of 73 degrees, cosine 13 degrees, minus cosine 73 degrees, sine of 13 degrees. And you're going to use the appropriate identities here. In this case, we need to find out which one of these sum and difference identities match up to the one that I have. Because in this case, I got the sine times the cosine minus cosine times the sine. That's this one right here. So that means I'll write that as the sine of alpha minus beta. Okay? So here, I can write this as the sine of the first angle, which is 73, I need to make a correction here. This should be 17 degrees, not 13 degrees. I apologize for that. Okay. This will be 73. But this should be 17 degrees, okay? So do make that correction there. And I will make the correction on the review sheet as well. Now, if you add 73 and 17, you're going to get 90. So this will be the sine of 90 degrees. And, of course, sine of 90 degrees, pretty much you can use that unit circle if you want to, but keep in mind that 90 degrees is going to be here. That's the y value. That's the sine of 90, 1. So sine of 90 would be 1. Okay. Okay. So do make that correction. It's not cosine 13, it should be cosine 17, and this should be sine 17 degrees. Otherwise, it's not going to come out correct. Alright, number 18. Solve the trigonometric equation 12 times the cosine square of x is equal to 3 on the interval 0 to 2 pi. And it's going to be on the interval from 0 to 2 pi. Okay, that's the trigonometric equation that we're going to try to solve. Alright, in this case here, we need to get the cosine of x by itself. We need to get rid of that 12 that's in front, so what I'm going to do here is divide both sides by 12. So that means cosine square of x is equal to, well, 3 over 12, I'm going to reduce that to 1/4. Now, I'm squaring the cosine of x. The opposite of squaring something would be to take the square root on both sides. And I'll also bring in plus or minus as well. So that means I'll have cosine of x equal to plus or minus. Square root of 1 is going to be 1. The square root of 4 would be 2. Okay? So now I got two answers here. The cosine of x is equal to positive 1/2. The cosine of x is equal to, let me move this over, negative 1/2. So now I need to find out what values of x where the cosine of x will give me an answer of 1/2. Well, the cosine is going to be the x-coordinate, which is going to be the 1/2. So in this case here, one value where the cosine is going to be 1/2 would be pi over 3. Another one would be, if you look down here, where you got 1/2 as the x-coordinate, that's the cosine. That angle is 5 pi over 3. So here I got pi over 3 as 1. And the other x value is 5 pi over 3. Now I want the cosine of x, I got the cosine of x equal to 1/2, so I want the values of x where the cosine of that angle would be 1/2. And I think there's two of those as well. Here's negative 1/2. That represents the cosine of x, or that angle. That angle there would be 2 pi over 3. So that's one of them. And then for the other one, let's see, negative 1/2 is down here. And that angle, that's the cosine. That angle where cosine would give you negative 1/2 would be 4 pi over 3. Okay. So these are all the angles where the cosine would give you positive 1/2 or negative 1/2. Pi over 3, 5 pi over 3, 2 pi over 3, and 4 pi over 3. They don't necessarily have to be in any particular order. Okay? So this is what problem 18 is. Let's see, problem number 19. Without using a calculator, evaluate each expression if possible. Here you'll be allowed to use the unit circle for the inverse, and I'll have those for you. So 19a is going to be the inverse sine of negative square root of 2 over 2. So let me pull up my graph for the inverse sine, or the unit circle for the inverse sine that I created. And in this case right here, this is the inverse sine, and we're dealing with negative square root of 2 over 2. So we need a y coordinate here, where it's negative square root of 2 over 2. And it's right here, because that y coordinate represents the sine. And the angle where the sine is negative square root of 2 over 2 would be negative pi over 4. Okay? So the inverse sine of negative square root of 2 over 2 would be negative pi fourths. Okay, part B. Now here we got the inverse cosine of the cosine of negative 4 pi thirds. So the first thing I need to do here is find what the cosine of negative 4 pi thirds is. Okay, so I'm going to do this down here. Cosine of negative 4 pi thirds. I like to use positive angles here, so if I add 2 pi to the negative 4 pi thirds, and I'll show you again. Let's see, excuse me, negative 4 pi over 3, and then plus 2. Math, change to a fraction, it'll be 2/3, or 2 pi over 3. So we're going to be finding the cosine of 2 pi over 3 using the unit circle. So in this case here, Using this unit circle, we're going to find 4 pi over 3, which is way down here. I'm sorry, 2 pi over 3. We're finding cosine of 2 pi over 3. That's up here. The cosine is this x value right here, negative 1/2. So, cosine of 2 pi over 3 is negative 1/2. So now I'm going to be finding the inverse cosine of negative 1/2. So this is from this. Okay? And now let's use our inverse sine unit circle to find negative 1/2. Okay. I need to use the other one if I can get to it. Okay, here it is. That's this. And that's from 0 to pi. That's for the inverse cosine. So now we need to find negative 1/2. The angle associated to that would be 2 pi over 3. So the inverse cosine of a negative 1/2 would be 2 pi thirds. And part C, the inverse cosine of the square root of 3 over 2. Inverse cosine of the square root of 3 over 2. So I need to use that inverse cosine circle. And the square root of 3 over 2 for the x value. If I can find it, it's right here. Because the x is the cosine. The angle associated to that would be pi over 6. Okay. So that's going to be problem number 19. And finally, problem number 20, draw a right triangle to simplify the expression sine of the inverse secant of the square root of x squared plus 144 over 12. Okay, so in this case here we got the sine of the inverse secant of the square root of x squared plus 144. And that's all over 12. So that's this right here. Alright, and it does say draw a right triangle here. So in this case here, here's our right triangle. I'm going to call this angle theta. And this inside is going to be representing theta. Now you have to think of the secant as 1 over the cosine. Well, the cosine is going to be the adjacent side over the hypotenuse. So if we're dealing with the secant, it's going to be the hypotenuse over the adjacent side. So this is your hypotenuse right here. The square root of x squared plus 144. And then the adjacent side is simply going to be 12. So now we need the length of this side right here, which I'm going to call B. And here we use the Pythagorean Theorem. A squared plus B squared is equal to C squared. So here the A is going to be 12, so that's going to be 12 squared plus the B is what we're trying to find, that's B squared, equal to C, that's the square root of x squared plus 144, and that whole thing is going to be squared. And then I'm going to simplify this. 12 squared is 144 plus b squared is equal to the square root of the x squared plus 144, and u squared will be x squared plus 144. And now to get that b squared by itself, we're going to subtract 144 on both sides. So you're left with b squared is equal to x squared, because the 144s on the left and the right side are gone. And then to solve for b, we take the square root on both sides to get b equaling to x. So in this case here, the length of this side is what x is going to be. This side is x. Alright, now I'm going to use that right triangle to find the sine of theta. Okay. So in this case here, the sine of theta would be the opposite side over the hypotenuse. So in this case here, the opposite side here would be your x over the hypotenuse would be the square root of x squared plus 144. And I'll give you credit for it if you leave it like that. Okay? So the sine of the inverse secant of the square root of x squared plus 144 over 12 will end up being x over the square root of x squared plus 144. Okay? So those are the 20 problems that you will see, well, similar problems that you will see on your first exam on Monday. Now, feel free to watch this video as much as you need to, and feel free to email me or pretty much call me if you have any particular questions about any of the problems that I've done in this video. All right, thank you very much, and good luck on your exam.